Let's go to Liquid 886 possible by party partition. Um, so we are going to give n people from these people are labeled from 1 to n. And we want to split the people into two groups with any size. So each a person may dislike some other person. So it gives us an array dislikes. Um, and it asks you whether it is possible to divide these people into two groups. So return true or false. The first example, we can put a one, because one and two, they dislike, so they need to be in the different groups. Um, and two and four, they are in different groups. So one and four, they are in the same. And so this example is return true because we can divide the people into two groups, one, four into one group, and two, three into another group. So what we think about is that there are several ways to do this. Actually, the first thing is that we should compose a graph for uh, every people. And what is this? It will need to go to the next one. That means that we have the picture for some people. He dislike this kind of people, right? And so we should have, for example, A, they need to have goes to a list of people as B, C, D, right? So for B, it should also goes to a list of people, for example, G, some different peoples, right? So we need to compose graph, and then we can do BFS or DFS, right? DFS or use a union find to check from one person to go to another person, and also to see if the next person, let's say we use the DFS way, right? Trying to see if we go to the next person, for the DFS, we are going to return true or false, whether it can be partitioned by partition. If it is any of the next, if it's return false, then it return false. And it need to check, for example, the next one already been marked a color, right? So we can use a color. If the color is equals to current one, then we return false. So so we can write code for this, right? Let's write it in DFS way. And we know DFS, we need to compose graph first. It's the integer. It's called graph equals new list should be n plus one, right? Let's put n plus one because this index, you see, it is from 1 to n, right? So we, for the index 0, we just put an empty list. So we can say arrays set O graph it goes to new array list. And what do we do is that for array is like in this likes, we're going to have graph is like 0 and is like 1. And also we'll have graph is like 1 and is like 0. So we're going to use a color array to mark groups new in class 1. Right? So what we do is for int I equals 1, I smaller n plus one. I, so let's say if this color I equals 0, right? And then we are going to do DFS, and this kind of DFS, we should have passing graph in I, and let's have flat the color. We can put the color. The value can be 1 or -1. So if it's not marked, let's just put this as 1, right? And also the color array. So if this return false, then we just return false. Otherwise, we just return true in the end, right? So this kind of Boolean DFS, we need a list integer graph, and we need a int parent, right? And int this flag is current color. We call flag. Okay, flag, and we need the color array. So what we do is that we need the color by current equals flag. So for int next in graph, it current. Um, for this one, DFS, we don't need to have a parent because if because the thing is that if it's already colored, right? Its parent is we already have the color array. So if we are coming from the parent, it's that index should already be colored. So we can use this color array to determine whether it is parent or not. So of course, if we add another parameter, for example, parent, right? And then for next, if next is parent, then continue. It is fine. But we can use a color array to do the same thing. So we don't need this, right? So it will say if this color next equals flag, that is, because we should be a -1, then we should return false. Otherwise, we'll say this if this color next equals 0, right? That means that if it is a negative flag, right, that means it's already been weighted before, right? So we don't need to DFS by the connected components. So that is only when this is 0, and we write, and DFS is false, right? Next. So this will be negative flag and the color. So if this is any of the next layer is false, we just return false. Right? Otherwise, we return true. And the Python code is very similar. So let's compose graph first. Our graph equals, so this list, right, for in range n plus 1, and for this like in this likes, what we do is that we are going to have graph this like 0 should append this like 1, and also graph this like 1. We're going to append this like 0. And we need a color array. Color equals let's this one by n plus 1, right? Let's define that DFS. This is Uh, so we're going to have current, which is an int, right? And the flag that is an int. Um, this one will return true or false. Cool. So what we do is that the color current equals flag. And we'll say for next in graph current. So we'll say if color next equals flag, then we're going to return false. And so we'll say if color next equals 0 and not DFS, and then not DFS. Let's say next minus flag, right? Then return false. Otherwise, we just return blue. And in our main function, right, just for I in range from 1 to n plus 1, right? And we're going to say if this color I equals 0 and not DFS I, just set this one flag as 1, right? And return false. Otherwise, just return true. The time complexity, let's say there are n person and dislike, for example, there are m dislike. So that is the age, right? This is a vertex age. So the time complexity will be O n plus m. And the space will be O m plus m as well, right?